Hello and welcome to the channel. Let us find the area of the square ABCD. We do not know the length of the side. However, side BC is extended to the point F and side DA is extended to E. And then EF is joined by a straight line. And if EF intersects square at the point M and N, then we are given length of FM, MN and NE. In other words, we know the length of tilted diagonal. We do not know the length of diagonal. However, we are given information about the length of tilted diagonal. Let us erase something that is not necessary for us. Since ABCD is square, angle B measures 90 degrees or it is a right angle. So does angle C, angle A and angle D. Okay, see triangle FCF to be a right angle triangle, and if it is a right angle triangle, then we can apply Pythagoras theorem to find sum of the side. Now, can we draw a right angle triangle whereby FE is the hypotenuse? The answer is yes. Let us draw it. Extend the side CB and then draw a perpendicular to CB from the point E. Let the perpendicular intersect CB, the extended CB, at the point, let us say P. Now, triangle EPF is a right angle triangle, and we know the length of hypotenuse EF, that is 10 plus 4 plus 6, that is 20. However, we do not know the length of other side. Okay, we are given that the figure ABCD is square and we want to find the area of square. If we know the length of side, then of course we know the area of square. Let the length of side be measuring x unit. Then BC measure x unit, so does DC and so does AB. Now angle P is a right angle B is also a right angle A is also a right angle. So all the three angles are right angle. If we consider the quadrilateral ABP, then fourth must also be a right angle. In fact, quadrilateral ABP must be a rectangle. And we know that opposite side of a rectangle are equal. And if AB measure x unit, since opposite side are equal, PE must also measure x unit. Okay. Now in triangle FEP, which is a right angle triangle, we know the hypotenuse to measure 20 unit and we know some information about base. However, we are still not able to find the length x by simply applying Pythagoras theorem. So what we will do is we will apply property of similar triangle. Let us draw perpendicular to AB from the point M. Now observe that this angle measures 90 degree, this angle measures 90 degree that we already know, this also measures 90 degree we already know. So if the perpendicular intersect AB at the point say Q, then MQBC is again a rectangle because all the three angle measures 90 degree. So fourth angle should also measure 90 degree. Once again, opposite side of a rectangle are equal. So MQ will also measure x unit. Opposite side are equal. Consider this triangle MQN. If I know the side NQ, then I can find x by applying Pythagoras theorem and I'm done. Let us try to determine NQ. Once again, we will apply property of similar triangle. These two angles are equal. In triangle MNQ, MNQ, and triangle FEP, MNQ and FEP, those two angles are equal, and so does this. And of course, this angle and this angle has to be equal. They measure 90 degrees each. all the three angles are equal, then we say that the two triangles are similar. Basically, when two triangles are similar, we can just expand one triangle to get another. Or we can write that since triangle MNQ is similar to triangle FEP, smaller hypotenuse 10 divided by bigger hypotenuse 20 must be equal to smaller side NQ divided by bigger side EP. Once again, smaller hypotenuse 10 divided by bigger hypotenuse 20 must be equal to smaller base NQ divided by bigger base, or 10 by 20 equal to NQ. We somehow want to find NQ. EP measure X unit. Okay, we can cross multiply to get 20 times NQ equal to 10 times X. Now we can divide by 20 to get NQ equal to 10 divided by 20 of X, or NQ equal to X by 2. Hey, we do not know the length of NQ. However, we can solve for X by applying Pythagoras Theorem to triangle MQN. By Pythagoras Theorem, square of hypotenuse, that is 10 square, must be equal to square of perpendicular, that is x square, plus square of base, that is x by 2 whole thing square. Can we solve for x? Of course. Sum of x square and x square divided by 4 equal to 100. We can take LCM and write it as 4 number of x square plus x square equal to 100. That gives us 5 number of x square divided by 4 equal to 100, or x square equal to 4 times 100 divided by 5. We can cancel 5 out and say that x square equal to 80. Now we don't have to solve for x because we just want area of square, which is x square. Lastly, area of square equal to x square unit, that is 80 units.